up the number of ways your event could happen, and you multiply. I got to be honest with you, though, it's going to get a lot more difficult. So let's just, you had asked, Andrew, you had asked about poker. And so like, let's take stock for a moment and see if you guys know some of the basics maybe about a deck of cards, okay? Some of y'all maybe play cards, some of you don't, I don't know. But how many cards are in a standard bridge deck? 52 cards, good. 52 cards are in a standard bridge deck, okay? How many suits are there?
4.
There's 4 suits. Can we name them?
Spades, clubs,
Hearts, and diamonds. Good. So there's spades, clubs, hearts, and diamonds. These 2 are what? Those 2 are black. These 2 are red. Everybody got that? How many denominations are in a standard bridge deck? Very good. Very good. 13 denominations. Now, I use that phrase because you think about like in a wallet, I might have a 20, a 10, a 5, a 1. Those are denominations of bills. Okay. But denominations of cards, there's 13 of them. Could you name them all?
Yes. Ace.
What do we call a 1?
Ace.
Ace.
It's also 30.
2,
11.
We're not talking about like card value. We're just talking about like card identity. So like there's an ace, and then 2, 3, 4, 5, 6, 7, 8, 9, 10. And then jack, queen, king. What are those jack, queen, and king called? Face cards. Good. So there's 13 denominations. Are there any jokers? Do those count in this equation at all? No, they do not. So you got 52 cards. You got 4 suits. You got 13 denominations. Okay, so here's the hard part. And we talk about counting, right? What if I asked you, okay, how many ways could you get a pair in a standard bridge deck? That's a hard thing to count. It really is. So what we're now moving towards is counting difficult things. Y'all first looked at some of these types of examples, and you're like, oh snap, I could count that. Just use the fundamental principle and multiply. Well, you tell me, what would you say about the number of pairs in a deck of cards? Landon? 51 times 52. Okay, I'm getting some ideas. Let me ask you this. Dylan, what kind of card are we going to pair up? We'll just use an example. A 7. Okay, lucky 7, baby. So how many 7s are there? There's 4. There's a 7 of diamonds. There's a 7 of spades, a 7 of hearts, and a 7 of clubs. Oh, sorry. Let me zoom back out. Thank you. Right? Now, we're going to use that notion of brute force here. Okay? We're going to say, hey, let me get a diamond and a spade, a diamond and a heart, a diamond and a club, and then I'm done with diamonds, aren't I? Then I got a spade and a heart, spade and a club. Why not spade and diamonds? Because we already did spade and diamonds. And then what do we got over here? Heart and club. So how many different pairs of 7s are there? There's 6 pairs of 7s. Okay, think fundamental principle of counting. There's 6 7s. How many other denominations are there? 13. So I'm going to say 6 times 6 times 6 times 6 times 6. Do I have to write them all out? Dot, dot, dot times 6. 13 times. All right. And that would be, actually, no, we'd probably be adding in that case. When did I start multiplying?
Oh, no.
I don't either. Bloop, bloop, bloop. How many pairs is there? 6 times 13 then? Yeah, there we go. Okay, there's my multiplication. I was looking for where my multiplication was. So there's 6 times 13. What is 6 times 13? 78 pairs. Okay, now let's go to something Landon said. What if we were talking about, okay, what if, how many just random 2-card combos could there be? Then we go over here and we think about, okay, I got my president, my vice president, and we'd say, how many cards are in the deck? 52. Once you've burned that first card, how many cards you got? 51. And so you would say, well, if there's 78 ways to get a pair, and there's 52 times 51 ways of getting anything, then you can start calculating probabilities. And later on this week, we'll talk about the definition of what probability is. By the way, that's what chapter 10 is all about. Chapter 10 is all about
That's how
probability.
they decide, like, on the, like, when you're watching poker.
Yes, sir. Absolutely. And that's a good point. They've got computers that will do a lot of these calculations for you. And I would imagine that like ESPN and some of those broadcast companies, they've got like a pretty robust user interface to where they know if such and such card is already faced up, then their computer is taking that into consideration, right? And so like it says, this guy's got a 13% chance to hit a straight draw. Well, they know that based on all the stuff that they've already seen and has been kind of removed from the deck, and that alters numbers that are left available. Okay. Now, here's what I'd like for you guys to do. I've gotten you to look at those first sort of 10, maybe like 6th grade level type questions. Now we're going to take a gander at some 7th grade level questions. Again, this is kind of what Delta Math deems as grade appropriate. So you may or may not have seen this stuff in 6th or 7th grade. I don't know. But can y'all read from the back? Y'all read those? Okay. I'm going to do similar. I'm going to give you about a minute. And I'd like for you to pick 3 of these problems and act as though you were going to explain how to figure them out now in light of our fundamental principle accounting.
Okay. Repeated, do you mean like another 6-digit number?
Correct.
What do you mean?
Yeah. So like repeated would be like if Ryan could serve as both president and vice president. We're like, nah, you can't repeat.
Well, is it just one?
What?
Is it just one for number one?
Well,
Will 6-digit number? So like you're asking for a 6-digit number, but they're just gonna be like next to each other, or
reused. So like the number 1, 2, 3, 4, 5, 6 is a 6-digit number.
Yeah.
123,456 is a 6-digit number. It doesn't use any repeats. So like the number
you're talking about number.
The number 111,111 couldn't be considered because that's repeating the digit pointer. So like I said, take you about a minute, maybe try and look through 2 or 3 of these. Randomly, you do not have to do like 1, 2, and 3. You can pick something that tickles your fancy. These are, while you're doing this, I'm gonna pass out a couple papers, but these are a lot, you have to be a little bit more thoughtful about how these work. There we go. And ready. Yeah. Did you say repeated?
What was it mean by no digits?
Repeated or reused is a better way maybe of looking at that. You know what I'm saying? So like if yesterday we went and bought Teddy Morgan a cell phone. He got his very first cell phone.
Why didn't you just give him your old one?
He's very excited. They told me an iPhone SE is no longer doable. So I've literally had it in the drawer and they were like, yeah, we can't use that. So anyway, he got a iPhone 14. And I don't know if y'all have gotten a phone in a while, but like they let you kind of sort of pick your phone number, not like 100%, but they were like, hey, we got 3 options for the exchange based on your zip code where you guys live. You can have a this, or this. Do y'all know what exchange means, by the way?
No.
Right. So like my growing up, my parents' phone number at their house was 901 386 3308. Right. That was their house phone. Now they live in Bartlett, and so a lot of Bartlett numbers have a 386. This is called the what's the word? Exchange. This is called the exchange. However, a bunch of my Collierville friends growing up, you know, when people had house phones, do y'all have house phones anymore? Landline?
I used to.
Anybody's grandma or anybody's got still landline in their home?
All
right. So like growing up in my friends that I was growing up with, they lived in Collierville. All of those were 853. Like every single one of them was 853. Okay, that lived in Collierville with the landline. So like that's what the exchange means. So if there's terminology that gets used in some of these problems, maybe try and figure out what they're talking about. And there you go.
Studies.
738, I think. It's different than mine. My wife and I have the same exchange. Ours is 356.
My mom was 356.
Your mom's a 356? Nice. Do y'all do Verizon?
Yes, sir. Why do you want to know that? You hear that, Chris?
Was he asking for my phone number?
Is that for my mom's phone number?
Oh, I got you. He probably already has it. He's a, no, I'm like, y'all are buddies, aren't you?
Yeah, but he does not have my mom's phone number.
Oh, I got you. I got you.
What is it?
So anyway, so like they gave Teddy the choice between 2 or 3 different exchanges, then we chose 738. So he's a 738 guy. And they were very generous because they let Betsy have a free Apple Watch. So my 6th grader now has a watch that she can call and text on. She's super excited about that. And they let Mrs. Morgan upgrade her 5-year-old iPhone 11. And they gave her an iPhone 16.
For free?
All for free.
So they get you a lot free.
Quote unquote.
Yeah, no kidding.
Then they hit you with all the taxes and stuff.
Yeah, dude, it was a bunch. I think I paid like $300.
Yeah.
That's crazy. Andrew wants to look at number 2. Okay, great. Anybody else, by the way, raise your hand if you looked at number 2 as well.
Got a number.
Well, we're going to test it out. We're going to see what you think. And Andrew, by the way, thank you for volunteering. I'm going to call on a couple other guys as well, but walk us through what your thought process was. 5-digit numbers can be formed that end in 5. That's okay.
Good. I got 4997.
7. By the way, do y'all use calculators for this? I hope so. You got your calculator out?
Wait, no, I won't minute. I gotta do some
Okay, redo the math. So I'm a visual guy. So like on number 2, check this out. I'm gonna say, it's a 5-digit number. 1, 2, 3, 4, 5. And I'm visualizing the problem. My biggest recommendation to you guys today is that with all of these counting and probability questions, try to visualize. All right, you got to.
I got 8999. Around. It could be completely.
I don't know. Let's see. How many options do I have for that first digit?
5, 4.
I've got 9. Good. And then Sam, why do you say 9? Yeah, 1 through 9. Why not 0? Boys, he came to play today. You wouldn't start it with the 0 because you think about your science class, you know the phrase sig figs, right? That's not a significant figure. I can't lead. I can't say I've got a 6-digit number. It's 0000002. That's not a 6-digit number. That's just a 1-digit number. So it can't start with a 0. It could start with a 1, a 2, a 3, a 4, a 5, 6, 7, 8, or a 9. That's 9 options. Now, how many options for your second digit? We got 10. How many options for the third digit? We got 10. Fourth digit? 10. Fifth digit? 1. Why 1? They said they already scripted it, and they said, hey, you've got to end in a 5. Now, what does fundamental theorem or fundamental principle of counting tell us to do with all these options? All right. And so, Andrew, revise your answer, and what do you get? 9,000.
I'm close. Oh, I rounded down.
That's okay. But do you guys see how that works?
Not really.
Okay, let's do another one. Andrew has already spoken up. Somebody else pick one that they kind of looked at, and we'll take a gander at it. What do you think, Zach?
Number 1.
Number 1. Okay. So how many 6-digit numbers can be formed? Let me change my color here. All right, so I got 1, 2, 3, 4, 5, 6 digits. And
What was the green one?
yes, sir, that was Andrew's number 2. Okay, so how many 6 digits can be formed? No digits can be repeated. So again, we're not going to start with 10 options in the first slot. We only got 9 options in the first slot because I can't start with 0. Okay, now how many options do I have for the second slot? This is a bit 9 again. Very good. Because although you can't use whatever you started with, now you can also use what? You can also use 0. And then after that, there are 8 because you've ditched the first 2 digits. There's 10 digits to choose from. You've already used 2 of them. Now you've got 7, 6, and 5. And then you would just multiply out whatever that is.
That one. I don't really get them.
Okay. So thank you, Zach. Did that tie in with how you kind of thought it would work?
No.
Somebody else, Finn? Okay. Did anybody get an answer for me, by the way, on number 1?
1,
Cal-
3, 6,
08?
08, 08.
Cool. Ron?
How can it be 9 on the second one?
At 0.
Yeah. Okay. So like here's some, and by the way, I got a lots to say about this topic, so I feel like I'm talking too much today, but let me get some of this stuff out of my brain. I'm gonna be open and honest with you guys. Of all the math topics in high school math, this is the one with which I'm least comfortable. Okay, and I've been teaching for 18 years, and like I know what I'm doing, but I feel icky. I don't like this topic because I always feel like I'm leaving something out. I always feel like there's that thing like, I forgot to consider that parameter of the problem. And I don't know if y'all have that feeling, but with probability, especially if something is worded, if something is worded ambiguously, then it's like, I wonder if there's that built-in assumption, like I have to assume what they're talking about. So like, for example, there's one about letters. Yeah. Well, how many letters do we have as options? There's 26 letters in the which alphabet? In the English alphabet. Maybe they're talking about the Cyrillic alphabet, like you would use in a Russian language. Okay. So, or maybe they're talking about the Hebrew alphabet or the Greek alphabet. We have to make an assumption when they say in number 9, when they talk about letters, that they're talking about what kind of letters? Good old-fashioned American letters, okay? And so that's one of the things that makes this a difficult topic, Grant, is that maybe things are worded ambiguously, or you have to make certain assumptions about it. Was there one about a die in here?
That was the last one.
The one up above? Yeah, Maria. Okay, so like look at number 9 right up there. It says Maria rolls a die. Now, is it talking about this kind of die, or is it talking about this kind of die? Now, if you're not here in person, you don't see what I'm holding. I've got a 6-sided die and a 10-sided die. What do you think they're assuming? It's a 6-sided die, because that's the one that's most commonly used is a 6-sided die. And so just maybe bear with me here on these kinds of probability questions. There's a lot of background knowledge that's required. Like you have to know certain things, like a deck of cards has 52 cards, or an exchange is the first 3 numbers after the area code of an American phone number. Things like that. It could be kind of difficult. Right. Now, second thing I wanted to say. Hey, Joseph, I bank you with me. Second thing I want you to key in on is I'm not saying that these are the actual, with these blue and the green example, these are not the actual numbers that we're talking about. What we're talking about is like how many options. So like if I wanted to write in red an example of a 6-digit number with no repeats, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 7, or 1, 2, 3, 4, 5, 8. Those are all 3 examples. Am I going to want to sit there and brute force that 136,000 times? No. Right? I have to have some mechanism by which I count all these possibilities. And that mechanism is the fundamental principle of counting, wherein we multiply the different options. Okay. How many 4-letter PIN codes can be made? Assuming that you're using 26 letters of the alphabet, it's 26 to the 4th power. Right. Let's see here. How many different ways could 9 unique novels be arranged on a shelf? Did anybody think about that one? Okay. After I set that first book on the shelf in that first slot, how many options do I have for the next book? And then? All right. So take a little time out with me right here. Which number was the book one? 7? Okay. Let's look at number 7 real quick. 9 times 8 times 7 times 6 times 5 times 4, 3, 2, 1. Anybody know what that equals off the top of your head? Why would you, right? That's not a math fact that you have memorized. But does anybody know what that symbol means? Have you seen that symbol, that exclamation point? 9 before? I love that joke. That's good. It's like, it's not just 9, it's 9, exclamation. That's not what the exclamation point means in this context. I think it's good too. Louder. It's called listen to it. It's called a factorial. Okay. An exclamation point is called a factorial. Now you've got one of these on your calculator. Can you find it? and we'll show you where it's at. Watch this, okay? I'm going to go, there's two places where you can easily find it. You can go math, and then scroll over to the probabilities tab. So, sorry, fellas. You can go math, you can scroll over to the probabilities tab, and then it's the fourth option, right? So like if I wanted on my home screen, if I wanted to do 9 factorial, I could hit 9, math, left, 4, and it's 362,880. That's what 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is. Okay? There's another shortcut that's a little bit faster. If I wanted to do 9 factorial, I could go alpha, window, 9. Alpha, window, 9. And that's your shortcut as well for factorials. Okay? Now, why is it that the factorial here is being used? Because I'm counting down. It's because I'm losing a book every time I put one on the shelf. Okay? Every time you put one on the shelf, you lose one. So this is known as counting in the big boy sense. Okay? It ain't easy. Let's do one more. Okay? Which one that we haven't talked about that y'all want to look at?
Number 6.
Number 6. How many? 4 number/letter pins can be made if no number or letter can be repeated. Okay, so I'm a visual guy. 1, 2, 3, 4. Now you tell me, how many options do I have in that first slot for the pen? Alphanumeric option. 32.
36.
36. 26. So there's letters, but then there's also 10 digits. So we would have 36. Now, no repeats means what? The next one's going to be 35, Andrew. You could have either a number or a letter. And is it okay? Like, could you get into your smartphone right now? Does it? I'm not asking for your passcode, but is it legit to have like a passcode that starts with the number 0? Is that doable, allowable?
No, that's what I have.
It doesn't
Yeah.
have a look.
No, we ain't talking about this example. We're just talking about like phones. Could a passcode start with 0? Yes. Could a passcode start with A? Like in this example, yes. So like, there's no restriction to the number of options for that first slot. But since it said no repeats, now there we go. I'll throw in an extra little kink. What if it had said no numbers can be repeated, but letters can be? That's a whole different ball of wax, because you got to break it up into two separate camps. Letters repeated, count them. Letters not repeated, count them. And then it's you would add the two together. Counting can be very difficult. Okay. Now, I'm wondering, could you figure out a way on your calculator? All right. You're gonna have to be creative with me here. Can you figure out a way on your calculator to determine what is 36 times 35 times 34 times 33 without actually entering in that as a multiplication problem? Can you do it using factorials?
Yeah, 36, alpha, windows, 9.
All right, that would give you 36 times 35 times 34 times 33 times 32 times 31 times 30 times 29 times blah, 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 all the way 3, 2, 1, and that'd be a ginormous number, by the way. But I don't want that ginormous number. I just want the first 4 factors of that ginormous number.
36 factorial minus.
Very close. Okay, we're very close. Say that one more time.
36 factorial minus 32.
Okay, now what mathematical operation? Correct. Good adjustment. Good adjustment. So a factorial is all about multiplication. And so what's the inverse off of multiply? Divide. Does that make sense, Zach? So very good. I love how you guys comboed on that. So, well, let me write this out. Check this out, okay? So like if I wanted this expression right here using factorials, I could do 36 factorial over 32 factorial, because what is 36 factorial? 36 times 35. Go slow with me, please. 34, 33 times what? Times 32. Factorial. Beautiful. So do you fellas see now what would get chopped off? The 32 factorial. And it's real nice because I don't have to worry about the 31, 39, 29, 28, 27. I don't have to worry about all that because it all gets chopped off there at the end anyway. Okay. So being creative about your factorials is going to be a facet of this chapter. Okay. Let me go ahead and show you my key for these bottom questions and just kind of let you peruse the answers. Can y'all see that all right?
It's 44
What's 44?
degrees outside.
No, I don't ever take that into consideration. I think it's much warmer by now. It was 32 when I got my car this morning.
Yeah.
It's cool.
Me too.
All right. Do you see any answer up there that like kind of shakes you and you're like, whoa, wait a minute, that's not what I would have got. So they asked two different questions. How many 3-scoop cones can be made from 12 flavors? Could I get my favorite flavor of Baskin Robbins ice cream is Cherry's Jubilee. Could I get Cherry's Jubilee, Cherry's Jubilee, Cherry's Jubilee, 3 scoops of that?
Yeah.
Shit, dadgum, right now I'm gonna have a heart attack if I eat that. But I could get it. So like that's where like repeats are allowable. So there's how many options for the first scoop, how many options for the second scoop, how many options for the third scoop? 12, 12, 12. And then they said, well, oh, wait a minute, what if no flavors can be repeated? What kind of a sadistic ice cream shop are we going to? Number one question. But number two, that would be 12, 11, 10. All right. Now, we're not done with class, but real quick, I want to drop in a little mental seed on you here. The homework is just 10 questions. 5 of them look like that top set, and 5 of them look like this bottom set. Okay. They classify these as 6th grade and 7th grade math questions. So it's on Delta Math. When do I want it done by?
All right.
Next time I see you. Okay. Next time I see you.
Bracket.
Landon, you okay? So like I'm after we're done with math. Next time I see you, right? Hey man. Uh-oh.
No idea.
Legitimately can't solve this.
For real, yo?
No way. Is that a 2 or?
These guys can't solve it.
Is that not? Is
I'll
that?
make sure
That's a
you're-
2.
Now here's what I want to know,
Look,
Mr. Perry. You guys listening at home have no idea what's just happened.
I'm sorry.
No, you're fine. You're fine. So, Mr. Perry, are you more inclined to kill the fraction or to combine the two terms on the left?
And if they do, they do us.
Oh,
Which doesn't make any.
that's disappointing.
It would just be.
No, I'm saying like your personal flavor of choice here, would it be to say 3.5x on the left, or would it be to say, hey, I got like what you just wrote up?
Oh.
You can do that.
Even if the fraction is like dividing by 5x, I'm gonna multiply everything by 5.
I got you. Hey, just smack them around a little bit. And by the way, is that shirt considered green?
I hope so.
Okay.
That was my goal.
No greenie, yes, Pinchy. No greenie, yes, Pinchy. That's a game my daughter plays. Get him, get him. There you go. Hey, real quick, last kind of maybe 4 minutes here with me, folks. Can you practice plugging in number 1 on your calculator, please? Go ahead and do the keystrokes. Practice that muscle memory. Find where your exclamation point, your factorial sign is. Absolutely. Okay, so I'm going to hit 10 and then alpha window 9. Yep, alpha window 9. There's your shortcut. Now, if you've got, like Grant, you and I've talked before, your older calculator, you're going to go the math menu route, okay? So, like, you're going to go for 6. Math left 4. Yep. And we get 5,050. Is that what we got, Grant? I mean, Bradley? I was talking to Grant, sorry. Practice plugging it in. Practice plugging it in. You good? Look, this is ACT skill. This is basic primary. You're going to be on the ACT. They expect you to be able to do this in your sleep. Okay.
I got.
It is 100% fair game.
That's what I got. That's what I got.
Good. Mm-hmm. But okay, look. So good. There you go. So Grant brings up a great point. Maybe on the ACT, they write out this question number 7, and I don't even know what the dump that is, and I don't know to use factoring, right? but now I do. And it's like, oh, that's the easiest daggone question on there. Okay. Now, we just took a look at number one. Y'all hanging in there with me? Okay. Hanging tough. Oh, number two. What in tarnation? I can't just plug this into my calculator now.
Why not? Yeah, you can.
Well, because my calculator does not have a computer algebra system, so it's not going to give me the polynomial answer that I'm looking for. It's got n stored as 0. It's got a predefined. Don't try and type this because the n that you've got on your calculator is.
So probably goes in error.
It's going to assume that Zach has stored a value for n sometime, or the default value is stored as 0. By the way, 0 factorial, I didn't tell my second period this. 0 factorial is defined as 1. That's a good job on writing that down. I like seeing pencils moving. And shame on me for not telling second period that. But hey, look, by definition just means the people that invented this aspect of mathematics made it. They made this rule. They said, hey, we're going to make it so 0 factorial equals 1. And we want to make sure we remember that.
That makes sense.
0 factorial equals 1. And you can test that out on your calculator. If you ever forget that, you can literally just do 0 factorial, and they're going to tell you it equals 1. It is a rule that they just made up. They said, and the reason for doing it is so that things like these operations that we get into, they work out nice. All right, so let me ask you this. Will J, can you help me? What is just like with words, what is 5 factorial? What does that mean? Excellent, beautiful. Okay, Andrew, what is 3 factorial just with words? 3 times 2 times 1. Okay. Adam Kelly, what is n factorial just with words? Like I gave Will J an example and I gave Andrew an example where I gave them numbers, and what did they start with? I said 5 factorial, and so he said 5 times blah, 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 blah. And Andrew said 3 factorial, so he started with 3 times blah, 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 blah. You're going to start with what? Good. So n factorial, and Landon, can I maybe lean on you to help a little bit with this? N factorial is defined as what? N times, good, n minus 1 times n minus 2 until we get to what? How about 3 times 2 times 1? Okay, that's what n factorial is. Now, Ben, let's upsize it a little bit. We're going to get the Wendy's biggie bag here. What's n plus 2 factorial? We think none. So just like Will J said, 5 factorial starts with 5. Andrew said 3 factorial starts with 3. Adam said n factorial starts with n. I'm giving you n plus 2 factorial, so it's going to start with what? N plus 2, and then you're going to times it by what? N plus 1. Why is that? Because we just drop it by 1 every time. Times it by what? N, and then n minus 1, and then n minus 2, all the way until what? 3, 2, whoops, 1. Now, if we're supposed to be, because I don't know what n is, but I know it's going to eventually, because it's factorialized, it's going to eventually incrementally count down to 1. Okay, so now, what do y'all notice these two divisions, or these two factorials being divided, does anything cancel out? Yeah, almost the whole kit and caboodle, doesn't it? Everything except those first 2 factors of the numerator. And so there would be, you could FOIL that out if you wanted to, but there would be my answer. Yeah. Everybody see how that works? All right. I'm going to pause the screen here. I'm going to end my sharing.